The second step in the concentration or the extraction of a metal from its ore involves the extraction of a crude metal from the concentrated ore. It mainly involves reduction basic process. See, the crude metal is basically obtained by what? Reduction of the concentrated ore. And this is what is the second step is, which is the second step of the major metallurgical process. This process of reduction of the concentrated ore to the crude metal involves two steps. The first is changing to metal oxide. Changing to metal oxide. See what happens is the metal is converted to the concentrated ore is converted to first the metal oxide. We know it is thermodynamically it is much more feasible to reduce a metal from its oxide form than to the crude metal than from its sulfide form. So what we do is we need to change the metals which are existing or ores which are existing in the form of sulfide and others to their oxides. Now the changing to metal oxides involves two steps, two processes, either calcination or roasting. Let us understand first what is calcination is. Calcination is heating the ore in absence or in limited supply of air or oxygen. See what we do in this. It is mainly done for oxides, hydrated oxides ores, for carbonates and for bicarbonate ores. We now hardly have any bicarbonate, so it's mainly done for carbonates, hydroxide and oxide ores. The main purpose is to remove water off crystallizations, to convert carbonates to their oxides, to remove the moisture, to remove the volatile impurities. That is why we use a little bit of oxygen like sulfur, arsenic, phosphorus, etc. And let us see what it is done. Like if we are having this hematite XH2O, when the heating is done in absence of oxygen, we get what? This simple Fe2O3 and the water of crystallization are lost. If we are having, suppose, like this lime calcium carbonate, when heated, it gets converted to its oxide. Like we have a dolomite or calcium carbonate, magnesium carbonate. When it is heated, it gets converted to calcium oxide, magnesium oxide, and CO2. So calcination is heating the ore, these oxides, hydroxides, carbonate ores in absence of oxygen or in a very little supply of oxygen, because we need to oxidize those volatile impurities. So this is what mainly is the calcination. The second is roasting. Roasting involves heating the ore in presence of oxygen. So the second step in this is roasting. Now as the name suggests, it's heating in presence of oxygen. It is mainly done for sulfide ores and the other form of ore which basically needs to be changed into the oxide. Mainly done for sulfide ores. Like what we do is zinc sulfide is there. When we heat it in presence of oxygen, we know we get zinc oxide and sulfur dioxide. We are having galena lead sulfide heated in presence of oxygen, it gives lead oxide and SO2. When it is mainly done for like cuprous sulfide, we heat it, we get cuprous oxide and the SO2. Now specifically, roasting of copper ores is done in reverberatory furnaces, in which what we do is we add silica. The main reason is because this copper ores also contains ferrous oxide, which when combines with silica forms FeSiO3, which is ferrous silicate, the compound called slag. So slags are the compounds which are formed by the combination of a flux with the gangue particles. This is flux added, this is the gangue particle. So what are flux? I hope you have done in the junior level. Flux are the chemical substances which are added to remove the gangue particles, and the compounds which are formed by the combination of a flux and the gangue are called slag. So for your ferrous silicate is slag. So they are separated out. Also remember, the SO2 obtained in this roasting process is mainly used in the manufacturing of the sulfuric acid. So usually the contact process, which is used mainly for the preparation of sulfuric acid, those plants are actually always along with the establishments where we are doing the metallurgical processes like roasting of these sulfide ores. The second step involved in the extraction of a crude metal from the concentrated ore is the reduction of the metal oxide to the crude metal. Now in this, what we do is basically the metal oxide is heated along with some special reducing agent, which reduces the metal oxide to the crude metal. Then the process simply involved is that this MO, when heated with reducing agents like coke or carbon monoxide, what we get is crude metal and the carbon monoxide. Now you need to understand at what temperature this heating is to be done with the coke, or which reducing agent is to be used, or which is more suitable for reducing the metal oxide to the crude metal. All these processes basically involves a deep thermodynamic study, because we need to understand that these processes are to be made feasible. And to make any process feasible, we need to have a deep thermodynamic study of that process involved, so that we can know that how it is to be made feasible. So first, let us understand the thermodynamic principle of extraction of metals.